Hello guys, how is it going? Welcome to Math 130, College Algebra. I'm Mike, and we are going to get right into our videos. In this video, and for these first few videos, we're just going to do a little bit of a review of some mathematical concepts that you should already be familiar with. In this video specifically, we're just going to go over radicals, general nth roots, and some properties of these roots when we divide, multiply, things like that. So just a quick recap of the nth root and rational exponents. We can take the nth root and write it as a fractional or rational exponent. Saying the nth root of x is the same thing as saying x raised to the power 1 over n. So if we have just any fraction whatsoever, any fraction of the form a over n, and we have that as the exponent of our variable x, by properties of exponents, if you take something that's raised to a power and you raise that whole thing to some other power, then you are multiplying those two powers. So x to the power a over n is equal to x to the 1 over n, that whole thing raised to the power a. And then in terms of a root, that's the nth root of x, all raised to the power a. Now there is one other way that we can write this. We can look at x to the a over n as x to the a, then raised to the power 1 over n, because the order in which we multiply things does not matter. So this right here is thus equivalent to the nth root of the quantity x raised to the a power. So these are just two ways we can write a variable raised to a rational power. This should just be a recap of previous math. Recall products and quotients of radicals. Basically what happens is if you're going to take the radical or the nth root in general of the product of two things, that is equal to the product of the nth root of those things on their own. And then if you're going to take the nth root of the quotient of two things, that's equal to the quotient of the nth roots. Adding and subtracting radicals gets a little bit more complicated. Just something you have to be very, very careful of. You can only add and subtract radicals when what's inside of them are the exact same thing. So I have a few samples here. I have 13 times the fifth root of 8 minus 4 times the fifth root of 8. So not only do what's inside of these things have to be the same, the roots themselves also have to be the same. So since these are both 5s here, and what's inside of both of them is the same, it's just the number 8, then we can subtract these two in this case. And when you're subtracting them, you're just subtracting the coefficients on those guys. So it's just 13 minus 4, or 9 times the fifth root of 8. The second sample here, the root we're taking, the cube root, is the same, but what's inside of these guys is not the same. Here we have x, here we have an x plus 4. So we can't take the difference of these two things. And then third sample here, just put a little x there to stand for the fact that we can't subtract these guys. And then this guy here, I have two roots here. What's inside of my roots is the same, but the problem is the root we're taking in these two cases are not the same. We're taking the 7th root of the first one, and then we're taking the 5th root of that second one. So since these radicals are not the same, we cannot add these guys just straightforward. We cannot say that this is 18 times some root of 4. We just sort of have to leave that as that is. So again, this is just a short, quick video, just serving as a little bit of a recap as far as properties of nth roots, taking those guys, running them as rational powers, and then how do you operate with these things? How do you take products, quotients, sums, and differences? In the next video, we are just going to take a little bit of a look back at polynomials and just how do we work with these guys here. So if you have any questions or comments, please be sure to reach out to me. Send me an email, send me a text, throw up the bat signal, whatever you have to do. Otherwise, until the next video, take it easy, folks.